This is the review from the Significant Figures and Scientific Notation quiz. I wanted to go over the areas that we struggled. I also wanted to kind of do a review before people took a retake. So we only had an average score of 79%. That was a little lower than our normal quizzes. That's why I'm doing this review video. Our low score is 43%. That's a pretty stinky grade. So you can kind of see our breakdown. We did have some 100s, so that was good. But let's talk through each question and make sure you understand what you did wrong and maybe what you did right. The first one was about scientific notation. The first factor of a scientific notation number should, blank one says, be between 1 and 10. If you go back to our lesson on scientific notation, there's a note video from me talking, and then there's also several other videos. But scientific notation, between 1 and 10, the first factor, because if it's less than 1, you have 0 before the decimal. And if it's greater than 10, you have more than one digit before the decimal point. So it has to be between 1 and 10. A negative exponent in the second factor of a scientific notation number indicates that the number is smaller than 1, that the number is smaller than 1. So a positive, it says that a negative exponent tells you that the number is smaller than 1, a little teeny number. A positive exponent tells you that the number is larger than 1. Most of you guys got that right. All right, so this one you had to determine if it was correct or not correct, so we'll talk about this a little bit. The first one is correct, and most of you got that right, because the first factor is between 1 and 10, and the second factor has a positive exponent of 8, and if we look at the standard number, this imaginary decimal point that would be right here is 1, 2, 3, 4, 5, 6, 7, 8 places moved to make the number between 1 and 10. The second one is not correct, and everyone who took the test got that one right, so I don't need to talk about it very much. But the first factor is not between 1 and 10 for starters, and that is what is wrong with that. And the exponent, though, 1, 2, 3, 4, would be correct if they had the correct first factor. Okay. Most people got the third one right, and it is correct because 4.58 is between 1 and 10, and negative 4 shows that this number is less than 1, and we would move this decimal place 1, 2, 3, 4 places to make the first factor between 1 and 10. The next one is not correct because I have 45,800, and so the first factor is between 1 and 10, but the exponent is negative, and this is a big number, so it should be a positive exponent. The last one is not correct. Most people got that, but 89 is not between 1 and 10, so that makes it automatically incorrect. And 7, 1, 2, 3, 4, 5, 6, 7. 7 would be the correct exponent if your first factor was correct. So since it is 89, to make this the same number, you would have 89 times 10 to the 6th. And that would only be if you were doing that within a math problem. But to turn it in as an answer is incorrect. Okay, significant figures. We did struggle with this a little bit. So I would encourage you at this one to go back and look at the video that we discussed significant figures rules and how to find them. But let's go through them here. The first one has 3 significant figures. So the first rule is all non-zero digits are significant. So the 9 and the 2 is significant. The second rule doesn't really apply here, but it's any zeros in between significant digits are significant. And the last rule applies here because the last rule says any trailing or final zeros in the decimal portion only. So this 0 right here is a final zero in the decimal portion. So we have 1, 2, 3 that are correct, that are significant figures. Well, the second one only has 2. Most people got it right. But you can see non-zero digits. Those are the 2. There is no decimal portion, so there's no trailing zeros in the decimal portion, and there's no zeros in between anything. And the third one is 2, because they're both non-zero digits. So everybody got that right. That was good. The next one has 4 significant digits, so we had a little struggle with that. Non-zero digits, the 9 and the 2. this 0 here is in between, so it would be significant. And then the last 0 is significant because it's a final 0 in the decimal portion. There's our decimal place. A final 0 in the decimal portion. Okay. The last one, we struggled a little bit with the last one, so let's discuss the last one. We had 2 significant digits. We're just looking at the first factor when we look at a scientific notation number. And so all non-zero digits are significant. So there's the 9 and the 2. That makes 2. And there's nothing else. So there are 2 significant digits in that number. All right, let's look at the next one. This was the most missed question that it seemed like anyways. We only had 50% of the people get the first question wrong. So let's digest this one a little bit. Round the number below to the indicated significant figures. So we have this number, 78.5436. And it asks you for one significant figure. The correct answer is 80. Because the 8 would be significant. The 0 is not significant because it's a placeholder 0. And we look at the number, the 8 is going to tell the 7 to go up. And we'd have 8, 0. We're rounding off the number there. Okay, the second one, 2 significant digits. In this case, we'd have 79 because the 5 right here is going to tell the 8 to go up. So it would be 79. Only 58% of us got that right. It would be 79. Okay. And the third place was 78.5 because we need 3 significant digits. And the 4 is going to tell the 5 to stay put. So it's 78.5. It would round off right there at the 3 significant digits. And then 4 significant digits, I did a little better. We got 64% accurate, but 4 significant digits would be 78.54 because the 3 tells the 4 to stay put, and we round it off right there for 4 significant digits. So hopefully that clears up the misconception there, and we have a little better communication when we're asking for a number of significant figures. It's just like when you're doing multiplication and you have to have a certain number of significant digits, well, you're going to have to round off your answer. And so that's where this question was coming from, and just to see if we were rounding correctly. All right. This one, 93% of you answered this one correctly, so I feel like we're kind of good. Addition, round the answer to the least number of decimal places, to the least number of places in the decimal portion of the problem. So you line up the numbers, line up the decimal points in the numbers, and then chop off the number at the shortest one. So you're going to round off the number at the shortest one. And subtraction is the same as addition. You guys, 97% got that right. Multiplication, looks like we have a little struggle, but 92% is a pretty good number. Multiplication, the least total number of significant figures in any number of the problem determines the number of significant figures in the answer. So if I have 7.89 times 2, well, 7.89 had 3 significant digits. 2 has 1 significant digit. So I would have to have 1 significant digit in my answer and round it off to 1 significant digit. Division is the same as multiplication. This one here, we are adding scientific notation. So I had to go through a few steps to add this. Okay, the first step for adding in scientific notation is you have to make sure that your exponents are the same. These are not the same. So we're going to have to employ Lars here. And when we employ Lars, we're going to make this 24 a 25. Lars is left add, right subtract. So if I need to make this a 25 and add 1 to it, then I need to move my decimal point 1 to the left. Lars, left add, right subtract, 1 to the left. So it would be 0.56879 times 10 to the 25th plus 9. So really, I'm going to have 9.56879, which is right here. This is a correct answer, this first response. However, it is not accurate to significant figures. I feel like the answer that we had up here had 1 significant digit past the decimal point, because when we add, we line up the decimal points, chop off at the shortest number of significant digits in the decimal point. So because I only had 1 place after the decimal point and we're adding here, I can only have 1 place after the decimal point to add in my answer. And it's 9.6 because the 6 tells the 5 to go up 1. So 9.56789 rounds off to 9.6 times 10 to the 25th. All right, so this one, 54%. It's pretty stinky. Correct answer. And the tricky thing about this is that every single one of these answers is correct. Well, this one is not correct, but the number, the first factor, has a correct part to it. So that means you really had to pay attention to what you were doing. So when we multiply scientific notation, you add the exponents. So 58 and 42 gives me 100. And then you multiply these numbers. When I multiply 2.601 times 5.1, I'm going to get 13.2651. That is the actual calculator number that you get. However, 13 anything in a scientific notation won't work. So we have to make the proper scientific notation. And when we look at this, we're going to employ LARS again. Left add, right subtract. So if I move my decimal to the left, which is what I'm doing right here, then I need to add 1 to the exponent. So that's where we get 1.3 times 10 to the 101st. And you might say, well, why is it 1.3? Well, when we multiply, the rules for scientific notation are you use the least total number of significant figures. So the number in our problem has 4 here and 2 here. So the least total number is 2. So our answer has to have 2 significant digits. All right, match the problem with the answer that has, here's another. Look at these problems. It's all the same problem. So you had to count significant digits every time. So if we look at this one, multiplication and division says that you have to have the least total number of significant digits in your answer, as in your problem. So this one here, I need to have the one that has 2 significant digits, because this has a whole bunch, but the second number, 62, is just 2 significant digits. So I need 0.023. This one, notice I have 5 significant digits. So I need 5 significant digits in my answer. This one, I have 3 significant digits because non-zero digits are significant, and trailing or final zeros in the decimal point are significant. I needed 3. This one, I have 1, 2, 3, 4, 5, 6. I need 6 in my answer. So this was all about knowing the rule for dividing and counting the significant digits correctly. All right, let's look at this last question. We got a 47% on it. And it's kind of a tricky one in that you are multiplying, so it seems really simple. Just plug it into the calculator. However, the rules for significant digits really kind of get sticky with this one, because we have 4, we have 3, we have 4, and then we have 1. There's no units on these numbers, so we can't use any of our exceptions that we might think about. So this one has 1 significant digit. So my answer has to match the least total number of significant digits, and that's 1. So my answer has to be 5. On the retake, I am going to ask you to type the word fox in a box. So you will type the word fox, F-O-X, when you are asked to do so on the quiz retake.